All right. In this video, we're going to do questions 13, 14, and 15. 13, 14, and 15 is on the basis of the fundamental counting principle. And remember, the fundamental counting principle is it's for us to find how many ways can we perform a sequence of events back to back to back. So number 13 says, provide an appropriate response. License plates is made with 3 letters followed by 2 digits. Followed by 3 digits, Eric. Come on. How many plates can be made if repetition of letters and digits is allowed? All right. So 3 letters, right? L1, L2, L3. Followed by 3 digits. Let's put that in blue. Digit 1, digit 2, digit 3. We're talking about the American alphabet in this case. So for the American alphabet, there are 26 letters. And when we say digits, we're talking about singular digits. And there are 10 singular digits in our number system. And those digits being 0 through 9. When it comes to the fundamental counting principles, we're trying to find how many ways can we possibly arrange something or possibly choose something when it comes to like combinations and permutations. So for my letter 1, I have a total of 26 possibilities I can choose from. So I'm going to put 26 right here because I have 26 letters that can possibly be chosen in this situation. Because I am allowed to repeat, and I want to highlight that as well. Let's put that in yellow. Because it says that repetition of letters and digits is allowed. That means for my option for letter 2, I have 26 possibilities. And the same thing for letter 3, 26 possibilities. For digit number 1, I have 10 single digits. So I have 10 possibilities to put here, 10 possibilities to put here, and for the last one, also 10 possibilities. And when it comes to the fundamental counting principle, you're going to multiply in between each of these numbers to find how many possible ways. If you want to rewrite it, you can write this also as 26 to the 3rd power times 10 to the 3rd power. Up to you. Let's multiply. Let's first clear this. 26 times 26 times 26 times 10 times 10 times 10. And our answer, which I'm going to write up here in red, 1,757,600. 1,757,000. Actually, you know what? No, my number is wrong. 17,576,000 ways. And there you go. All right. Let's move on to the next set of questions. Let's close this up. Number 14 says, how many 4-digit codes can be formed using digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 if the last digit cannot be a 1 or a 0, a 0 or a 1 or a 2, and repetition of the digits is allowed? Okay, so a 4-digit code. Digit 1, digit 2, digit 3, digit number 4. There's a restriction on digit number 4. And the restriction is it cannot be a 0, 1, or 2. So I'm going to write that down right here. Okay. Every other digit is fine the way it is. So, how many possibilities can go for the first digit? Well, once again, I have 10 digits. So I can put 10 right here, 10 possibilities. When it comes to my second digit, there's also no restriction, and it also says that repetition is allowed. So that means I have 10 possibilities to put for the second place. How many digits can go for the third place? There's no restriction, and repetition once again is allowed, so we put a 10 here. But for the last digit, it's a 0, 1, or 2. It cannot be rather a 0, 1, or 2. So that means I'm going to cancel out my 0 here, my 1 here, and my 2 here, which means there are only 7 options that can go here. And when I multiply that, that's going to equal to 7,000 codes. 7,000 possible codes. All right, guys. That's it for number 14. Let's do number 15. Number 15 says, how many different 4-letter radio stations calls can be made if the first letter must be K or W? Repeats are allowed, but the call letters cannot end with an O. So, 4-letter radio station. 1, 2, 3, 4. So letter 1, letter 2, letter 3, letter 4. We have some restrictions. The first letter must be K or W. Let's write that down. And then the last digit, which is here, cannot end with O. And once again, it says that repeats are allowed. All right. If the first letter must be a K or a W, there's only 2 possibilities we can have, a K or a W. There's no restriction on the second or third letter. And there's 26 total letters in our alphabet. So we can put 26 here and 26 here. For the last letter, it cannot end with O. So out of the 26 letters in my alphabet, I am excluding the letter O for the last digit, which means there are only 25 options that can go here. And once again, we can multiply to find out how many possible radio station calls can we have. Open up our calculator. Let's multiply 2 times 26 times 26 times 25. And that's going to equal to 33,800 possible call letters. Radio calls, whatever. You get the gist. All right, guys, that's it for the video. Hope it was helpful. I try to take my time to break this down as much as possible. Pay attention to the word choice, and I'll catch you in the next one.